So here's our code here. We've got our main loop, which just sets everything up for the most part. Down here we got a little while loop that outputs the distance measured for the ultrasonic sensor, and just outputs the difference in time for the pulse that gets sent out by the ultrasonic sensor and the distance from the ultrasonic sensor to the object. Most of the actual magic happens up in the interrupts. Our timer 0 interrupt just is set to have the measurement cycle happen at a frequency of 30 Hertz. At the start of the measurement cycle, it sets timer 3 to interrupt in 100 clock cycles, and also pulls up RC3, which is our trigger pin for the ultrasonic sensor, and you can kind of see that over here in the graph. It just pulls that high, and then 100 clock cycles later, timer 3 interrupts, and it pulls the pin RC3 back down, and also sets itself to 0. So we're not going to be interrupting timer 3 every 100 clock cycles. It'll just wait until timer 0 is ready for it to get started back up again. The last interrupt that we're doing is the timer 1, which has a capture feature, I guess, which basically captures the rising edge of this echo pulse that we're getting from the ultrasonic sensor, and then it sets itself back to 0, so that we're just at 0 when we're counting for the timer, and then waits for the falling edge to happen, which is what's happening over here. Once the falling edge happens, it records the time as DT, and then that is used in this while loop down here for our distance and time calculations. If you'd like more information, this code will be available on GitHub. Thank you. Alright, here's our board here. We have it set up with the ultrasonic sensor, outputting the time of travel for the sound wave from the ultrasonic sensor to the object and back, and the distance from the ultrasonic sensor to the object. As you can see, as the board gets closer, the distance decreases. As it gets farther away, the distance increases. And that's about it.